Okay, this is actually my fourth attempt at finishing up this video. My camera is not behaving well. It just ran out of memory. So here we go on this second problem on the second page. It's a physicsy kind of a problem. I've got this buoy going up and down in the water from a 20-meter height. It's going up and down 5 meters. That's the position. The velocity then is the derivative of that. So the derivative of 20 is 0. This is just 5 times the derivative of sine is cosine. Don't mess with the inside, then take the derivative of the inside because of that t. That's just the coefficient, comes out. I simplify it, clean it up a little bit, sub in and evaluate for 0. Evaluate it at 10. I get my 2 answers, put units on that. The derivative of the velocity then is the acceleration. So again, just be careful. It's going to be a simple little chain rule type problem. On the real test might be a little bit more complex, but don't get psyched out. Just grind it out. This is the acceleration then. I evaluate it at 0 and I get 0. I evaluate it at 10. I get the sine of 5 pi over 2. That just becomes 1, and there's my answer. All right. No calculators, so just exact answers. So then on to what are called orthogonal curves. These are curves that at the point of intersection, they're perpendicular to each other. So you have to find that instantaneous rate of change to see what's really happening at that moment of intersection. I evaluate each of these by using implicit techniques. Well, not this one so much, but this one definitely. It's worth knowing what these shapes are. It's worth knowing that if you have x squared plus a y squared, if the coefficients are different, it's an ellipse. If the coefficients are the same, it's a circle, okay? Parabolas, one is squared but not the other. If it's a minus, that's a hyperbola. That's when it's like a turned inside out ellipse. You can't have, in this case, a y value because you'd have a negative square root. You can find that in our book. We can talk about it in class if that's important. You maybe should know that from pre-calculus days. Anyway, I just evaluate it to sketch my my graph by letting x be equal to 0 and then solving for y. Y is the square root of 1.5, which is about 1.2. When y is 0, x squared is 3, so x is plus or minus the square root of 3. That's a little bit less than 2. So I find these 2 intercepts in the x, find the 2 intercepts in the y, sketch my ellipse. The parabola is super simple. You might even get lucky and see that where they intersect. If you don't get lucky, you have to solve. So the easy way to do that is to say, well, if y is equal to x squared, in place of x squared, I'll set what it's equal to. That's y. I have an equation. Yeah, it's a quadratic, but there's only one variable. So I smack it with quad form, or in this case, it's even easier. I can just factor it. My 2 factors then are 1 and negative 3/2. This one is not going to be useful because it's a negative. I can't find a square root, a square that gives me a negative. So I can choose either of these 2 points. I went with the positive one because it's easier. When I found the implicit differential, I get y prime is equal to negative 2x over 4y. When I plug in 1 for x and 1 for y, I get just negative 1/2. When I do that with the parabola, I get the very simple y prime is 2x. When I plug in just the 1 for the x, I get 2. And these guys are indeed opposite reciprocals, so that's perpendicular. That is what it means to be orthogonal. On to the last problem. Use linear approximation techniques to estimate this. I've got the 6th root of 64 raised to the 7th as my easy, convenient. I try to find something that's close to that. It's not going to be too much of a stretch for you to come up with that. Then I think of it as a function, which is some number to the 7/6 power. The 6 is the root, of course. The 7 is the exponent. When I take the derivative of that, simple product rule, bring that out front, subtract 1, I get 1/6. Now I plug in 64, and I get, with my derivative, I get the 1/6 exponent of 64 is 2, and then 2 times 7/6, the 2's cancel, and I get 7/3, which is 2.33. So in the language of differentials, that's the little bit extra I'm going up. When I go over 1, because 65 is, I wrote it down somewhere, 64 plus 1, when I go over 1, I'm going to go up 2.33 because that's my slope right there. Then I add that on to what I know to be 128. So my answer is then about 130.333. Check that out in a calculator. Okay, good luck.